Okay, let's talk about this a little bit. So, problem like this, they're wanting us to completely factor the polynomial. So here's the polynomial we're trying to break apart. It's got 4 terms, but factoring by grouping would fail, wouldn't work. So we would be stuck, except they give us some information, right? They tell us this. I want you guys to interpret this for me. What does this mean? Right there. No.
Well, 1 is equal to.
It means,
-1 is.
okay,
Well, I just know that it's 1 because
Don't you have to
zero.
multiply the whole equation by -1?
I'm not multiplying it by. This is saying if, now think about this, if f of x is this, right? That's saying when I plug in x's to the function, this is the recipe for what I do to them, right? So this is saying that, okay, now if I plug in a -1 for the value of x, I'm going to get back 0 for the value of the function, right? So that just means I'm plugging in -1 for all the x's and evaluating, right? Okay, so the way we say that is f of -1 equals 0, but I want you guys to be able to actually say the words. I want you to be able to tell me, what does that mean? What would we call -1 then?
A factor.
It's not a factor. It's a value of x, but it's a special value. It's the value of x that makes the function equal to 0. So we call it a 0, right? So this is saying then that x equals -1 is a 0 of f of x, right? That's a value of x that makes the function 0, okay? So how does that help us here? We're trying to factor this thing, right? So we have to be able to make this connection. I want you to get to a point where this is, the two are just interchangeable. If we're given a 0, that corresponds to a factor, right? Or if we're given a factor, we can make that correspond to a 0. The two always go together. So what's the factor that goes with this 0?
+1.
Well, when you say +1, that's part of it.
X plus 1.
It's x plus 1, right? So when we want to turn this into a factor, so x minus -1 or x plus 1, right? If I subtract a negative, I'm just adding. So x plus 1 is a factor.
And then this is when you divide and use 1 in the synthetic division.
We'd use the 0, which is -1, right? Okay, so these go together. The 0 and the factor are always interchangeable, right? Depending on which one we need for that situation. Okay, you betcha. So you see then that when I take this function right here and I factor it, so one factor we're going to get is x plus 1, guaranteed, because we know that -1 is a 0. And all I have to do is subtract the 0 from x to get the corresponding factor, right? But what we're looking for is the other factor that goes there, right? So algebraically, what would I do to solve for the missing factor? Let's just call it, for now, let's just call it f. How about? Let's just call this capital F, and that's the unknown. That's the other factor that's being multiplied by x plus 1 to give us this. What do I do algebraically? If I want to isolate something, how do I undo multiplying by x plus 1? Divide. Just going to divide both sides by x plus 1. Right? So if I do that, the x plus 1's cancel, and whatever the missing factor is, it's equal to that quotient, right? So how am I going to get that easily?
Synthetic.
Synthetic division, right? The bottom is linear, so we don't have to do that ugly long division. We can just do synthetic division. Okay, so doing synthetic division then. Let's set that up. So, Aras, what number goes in the bracket?
1. Oh, sorry.
Is it? What's it going to be? What's the number? Do you remember what's the number that goes in there if I'm dividing? That's it. What is it again? -1, yeah, because it's the zero is what we want, isn't it? We want the zero of the function. So let's see. So this is the -1 is going in there, right? What are the coefficients?
6, 7, -3.8.
Good, and you gotta be, and that's correct. You gotta be a little careful. When people make mistakes on this, a lot of times, if you just quickly write the coefficients down, you might miss a zero, right? In this case, there are no missing powers of x, so I don't need to include any zeros. 6, 7, -34, -35, and that's my remainder box. Remember what the remainder box also did though. Yes, it's the remainder, but it's also what we used for synthetic substitution to tell us the value of the function, right? So when I plug in -1 to my function, this is giving me either one of two things. You could think of it as being the remainder, or you could also think about it as being the value of the function when I plug in -1. Well, what is that value?
0.
It's 0, right? We know right from there, don't we? Right? So that 0 is telling us that that answer is 0, right? Two ways to think about it. Either because that is literally the value of the function, or because we know this is a 0, it means that this factor has to divide in evenly, so we have 0 remainder. Either way, they mean essentially the same thing. Okay, so what we really just need then is whatever ends up being right here, that's going to tell us what the factor is, the other factor is. Everybody agree?
Yeah.
Okay, so let's find out. What do I do to do this synthetic division process? Bailey, what's the first thing I'm going to do? Gotta drop the 6. Good. Then what? -1 times 6. What is that? -6, and I add. So what do I get? 1. -1 times 1 is add. -1 times -35. And of course, it had to add to 0. And it did, so we know we did it right. So then this is really telling me, down here, this is really telling me what the other factor is. Now, what's that 30, what column is that in?
That's the constant.
Constant,
X.
x,
X squared.
x squared. So we're gonna get 6x squared plus x minus 35, right? That's what's going to go there, right? So then we could say that so that's where that got us then, right? So now that allowed us to factor this big initial polynomial, right? We factored it down to, well, we knew we had an x plus 1, but by synthetic division, we figured out the other factor is 6x squared plus x minus 35, right? And so now the question is, where do we go from there, right? Because when we're trying to factor something, we have to keep going until we can't go any further, right? So we've got to deal with that one. How are we going to deal with that one? We got to see if we can go further with it. There's two ways we could do this. And I want to just review both of these. We talked a little bit about them yesterday, but I want to hit them one more time. So we could use bottoms up, right? Because if we're trying to factor a quadratic trinomial where a is not equal to 1, those are the harder kind, right? Those are the kind where we need to use bottoms up. So what's that look like? If we do bottoms up, we're trying to factor this part. So I've got to find numbers that multiply to AC. Well, what's A times C? 6 times negative 35. What's that going to be? What's 6 times 30?
-210.
It's going to be negative 210. 6 times 30 is 180. 6 times 5 is 30. 180 plus 30 is 210. And it's negative, right? So we gotta multiply to negative 210, right, because they have to multiply to AC. We're multiplying to that, and we're adding to B, which is what?
X.
No.
No?
1.
What?
Coefficient of X is 1, right? So we gotta add to 1. So let's think about this then. So the magic numbers that we need to find are gonna be, they're gonna have to be, what are the signs gonna be? So when we set this up, we're gonna end up with, my magic numbers go here and here. What are the signs gonna be? If they multiply to a negative, what's that tell you about the signs? Positive and negative, and if they add to a positive, they're
Positive.
positive. So we'll put the positive one first. That's gonna be the bigger of the two. So now we just gotta find those numbers that multiply to negative 210 and add to 1. Well, we could do this a number of ways. We could just go look for all the factors of negative 210, which is the way we've done it in the past, and that's fine. Or we could also say the positive one is how much bigger than the negative one again? No? When I add them together, when I add the two numbers together, I get positive 1. So how much bigger must the positive one have been than the negative? 1, right? Because they almost cancel. But the positive one, the negative one canceled out all but one of the positive one, right? So when they add to 1, that tells me the positive one is 1 bigger. So to me, an easier way to do this, they'll both work, but an easier way to do this would be to just look for numbers where the positive one is 1 bigger than the negative and see what the products are, and just pick the ones whose product is negative 210, if they exist, right? So we could start with, for example, how about positive 13 times negative 12 is gonna give us 156, negative 156, or, negative 156. Okay, that's not big enough, right? It needs to be negative 210, so I gotta make the numbers bigger. So let's try, how about 14 and 13? 14 and negative 13. Well, that's gonna be negative 182. So it's still not big enough, right? So let's try 15 and negative 14. What's that? That works. Okay. So that's our winner, right? Those are the magic numbers. So we're gonna put our 15 there and our negative 14 there, but with bottoms up, we don't stop with the magic numbers, right? When we get the magic numbers, what do we have to divide each of them by? By the leading coefficient, right? By A. So we're gonna divide each of them by, what number? Let's use, what have we used here? Green. We're gonna divide both of them by 6, right? And then all I've gotta do with bottoms up is I just have to reduce the fractions, and then after I reduce the fractions, I go bottoms up, if I'm left with a fraction, right? So what does 15/6 reduce to?
6x plus
5 over 2.
It reduces to x plus, what's that fraction? Say it again. 5 over 3 goes into both of those. 3 goes into 15,
5
3 goes into 6,
Oh, 5 over 2.
5 over 2. And then how about over here? 14/6 would reduce to, what goes into those? 2, I guess? 7/3?
Yeah.
Okay, so if either of those fractions had reduced to an integer, then that'd be done. I don't have to go bottoms up, but because they didn't, after I reduce, I'm essentially just gonna multiply each one by the denominator, which is the same thing as just taking the denominator and making it the coefficient of x. Taking it from the bottom of the fraction up to the front, right? So I go bottoms up. So then what does this become?
2x plus 5.
2x plus 5, and this becomes 3x minus 7. So those are the factors of the blue factor, right? So what's my final answer going to be? If I want to write this in factored form, I've got those two plus what else? Not plus, but what's the other factor that's being multiplied? X plus 1, right? Because x plus 1 is the one that was given to us, right? Everybody see that? Okay. So there it is. That would be our answer in Moodle, right? So that's how we could do it using bottoms up. How would we have known that bottoms up didn't work?
We did
we couldn't get magic numbers, right? Does that make sense? But I mean, if we couldn't find magic numbers that did this, that multiplied to AC and added to B, then bottoms up would fail, right? There's one other way to do this. We could also, and this is a pretty good trick, right? Remember that we can always associate a factor with a zero, right? So we knew that the 0, -1 gave us the factor x plus 1, right? So if I could find, rather than trying to directly find the factors, if I found the zeros of this factor, I could take those zeros and turn them into factors, right? So let's do that. We could set this equal, because really we're just trying to find when this whole thing equals 0. So we could set this equal to 0. And we could solve this with the quadratic quadratic formula. What am I saying? Right? Okay, we can solve with the quadratic formula, and if the quadratic formula gives us answers that don't have square roots in them, then those will turn into factors, right? If it gives us some kind of wacky square roots, then we know that it doesn't factor, right? So let's try that. So if I take this equation and I apply the quadratic formula, that's easy to do. What are my values of A, B, and C in this equation?
6, 1,
6, 1, and -35. So A is 6, B is 1, C is -35, right? So we can do the quadratic formula then. We get x equals -b plus or minus the square root of b squared, which is just 1, minus 4 times 6 times -35. We're going to divide the whole thing by 2a, so what's that? 2 times 6, which would just be 12, right? So let's just do this on the calculator. So I'm going to use the fraction template. I can just go alpha F1 to get the fraction template. And then on top we're going to do -1 plus square root of 1 minus 4 times 6 times -35. I guess I should have probably done that, huh? Okay. All divided by 2 times 6. And that gives us an answer of 7/3. Okay, so one answer is 7/3. But the quadratic formula has both a plus and a minus there, right? It says plus or minus square root of b squared minus 4ac. So I got to change that to a minus. Well, in the graphing calculators, I can just go up and grab that calculation. And if I hit second left, it takes me clear to the left. I can just go over and take that plus and make it a minus and hit enter. And the other answer I get is -5/2. So look at the two solutions we get then. So the two solutions are x equals 7/3 or x equals -5/2. What's our recipe for turning a 0 into a factor? Dalton, what's our recipe for turning a 0 into a factor? What did we do at the beginning with that? Don't remember? So if we go back,
It'd be like x minus 4 plus whatever.
look what we did here on the very first page. If we had the 0 of -1 to make that a factor, all we did was just subtract the 0 from 1 or from x, right? Right? So we can do that here too. If I've got this factor, I can just subtract that. So x minus 7/3 should be one of my factors, right? And then the other one should be x minus -5/2, right? Okay, and then I have to just go bottoms up with those, right? Because I don't want fractions in there. So, and this ought to look familiar. On the last page, right there, look at that. x plus 5 halves, x minus 7 thirds. Right here, x plus 5 halves, x minus 7 thirds. Hey,
Maisie's here. She's next door.
oh, okay. Where is she?
Sorry, man.
Mrs. Wilson.
What's she doing in there?
Goofing off, apparently.
She's
Okay.
with
Okay, all right. So, anyway, so if we go bottoms up, what's that gonna give us? That's gonna give us 3x minus 7 times 2x plus 5, and then we out in front, we have our x plus 1, same as before, right? Okay, make sense? All right. What about that? What am I gonna do? Okay, why don't you move over here, please? So what am I gonna do there? Right, now this is easier in a way. That's the factor, isn't it? But this time, if you read the directions, it's not asking us to factor the polynomial, it just wants us to find all the real zeros. So it gives us 1, doesn't it? Right? It gives us the 0, x equals negative 2 is a 0, right? Okay, I just have to find the others, right? Well, how am I gonna find the others? Those are gonna be the solutions to the equation I get when I set that thing equal to 0, but that's a pretty hard polynomial to solve, right? We'd wanna find the zeros, instead we'd wanna maybe whittle that down and get a smaller polynomial that we could factor to find the zeros, the other zeros, right? So we would then know that we can do synthetic division, can't we? I know that if this is a 0, it's gotta divide evenly into this polynomial. So we get 36, 117, 94, 13, and 10. And what goes in there for sure? 0, because it's a 0. Negative 2 is a 0. Okay, so if we do the math, bring down the 36. What's 36 times negative 2? Negative 72. If I add those up, what do I get?
45.
45, good. Negative 2 times 45. Add them, what do I get? 4, good. Times negative 2. Add them. 5. And then negative 2 times 5 is negative 10, and it works, it adds to 0, right? So then this must be the other factor that we get when we divide by x plus 2, right? So all I really need to do then is find the zeros. To get the rest of the zeros, I'm just gonna find the zeros of this polynomial. Well, what's that gonna be? If I write that as a polynomial, that's, what is that? Constant, coefficient of, okay, so this is just 36 x cubed plus 45x squared plus 4x plus 5, and we want to find the zeros, so I'll set it equal to 0. Okay, this is more manageable, right? Now I've got 4-term polynomial. What's my strategy for 4 terms? Grouping. Good, so we'll just group this. So we'll split it up. If we look at the left group, what's my greatest common factor?
X squared.
I can do a little better than that.
9x squared.
9x squared, good. So I've got a 9x squared. If I divide each of these by 9x squared, what's that giving me for the leftovers? What's 36x cubed divided by 9x squared? 4x.
And then 5x.
And then 45x squared divided by 9x squared?
Or just 5.
5. Okay, good. So we're rolling here. Then what does that tell me about with the other group over here, the right group? What does the leftover need to be? 4x plus 5. Okay, so 4x plus 5. And what would have to be multiplied out front to get that? What times 4x is 4x? 1, right? So that's all I can do is factor out a 1. I can't do any better than that. Let's check everything to make sure. Is 9x squared times 4x 36x cubed?
Yeah.
Yes. Is 9x squared times 5 45x squared?
Yeah.
1 times 4x is 4x, obviously, and 1 times 5 is 5. So it all checks out. So now, what's the last step in grouping then? Yeah, I've got to factor out
Yeah, so
the common factor, which is the leftover factor,
Yeah.
right? So we're gonna
4x
get,
plus 5, and then squared out 5.
so we're gonna get 4x plus 5, and then what's left behind if I do that?
Oh wait,
Okay, I'm gonna get it good. I'm gonna get a 9x squared from the first group, right? We're gonna get our plus, and then we get our 1, right? So that's what's left. Well, what were we really doing here? The whole time, we were trying to factor this, but it's all set equal to 0, right? So we wanted to factor this, so we could apply the zero product property and set the little factors equal to 0 and solve, right? So this is really equal to 0. Well, let's find the zeros. The only way this can work, remember that old zero product property, the only way I can multiply and get 0 is when I multiply by 0. So either 4x plus 5 equals 0, or 9x squared plus 1 equals 0. But what's going to be the answer to this one? What are the 2 steps to isolate x? Subtract 5 and divide by 4. So I get x equals negative 5/4. There's a 0. Now what about this one?
you would minus 1,
Okay, I would minus 1.
and then you do the square root of each side.
Okay, so I'm gonna, and divide by 9,
you divide
right?
by 9, and then you do the square root.
So x squared would equal, I'll subtract the 1 to that side and divide by 9, right?
And then you square
And then I'm gonna end up getting x equals, I'd have to put a plus or minus there, right? Square root of negative 1/9. Well, what's the red flag there? What's gonna happen to that one? Yeah, I got a negative inside the radical, right? So what's that gonna guarantee that I get? I'm gonna get an I, right? But the instructions wanted only the real zeros. Is that real? It's imaginary, right? So we know right away then that this one is gonna give us, we can just forget about this guy, it's gonna give us no reals. And we could have even known that before we started to try to solve for x. Because, I mean, you can think of it really 2 ways. If you think about this, kind of just think ahead a little bit. You know I'm gonna have to square root. And then on the other side, I know I'm gonna get something negative, right? So right away, red flag, it's not gonna work. The other way you could look at it is what's the only possible pattern that could match this 2-term polynomial? Sum of squares. Sum of squares doesn't work. Sum of squares never factors, never gives us real results, right? Never gives us real zeros. So either way you look at it, that one's gonna fail, but this one gave us a 0. So what would I put in Moodle then? Here's the answer box in Moodle. It wants all the real zeros.
It'd be negative 5/4 and negative 2.
Good. Negative 5/4 we found, and negative 2 was given to us, and it wants them all, including the given 0, right? Make sense?
Yeah.
Okay. I'll let you work here first. Not much, but you get a little bit of time to work. Okay, one thing, let me just say one thing. This is, you guys know here that